And the crazy part is, some of these LangChain workflows are now handling millions of dollars in transactions daily for companies like Stripe. I mean, that's not just a toy anymore, right?
Millions? That's significant. But I still see so many engineers struggling to move beyond the basic hello world examples. What's the disconnect?
Exactly. It's like everyone's got the Lego bricks, but nobody knows how to build a castle. They're missing the architectural blueprint. And that's where understanding chains, tools, and the orchestration layer becomes absolutely critical.
Okay, so let's say I'm building a customer service chatbot. If I just throw an LLM at the problem, what breaks down? What's the real cost of skipping this architectural thinking?
Well, picture this. Your chatbot gets asked a question it doesn't know the answer to. Without proper orchestration, it either hallucinates a response, which is a disaster for customer trust, or it just gives a generic "I don't know" response, which is equally frustrating. The cost? Lost customers, damaged reputation, and a support team drowning in escalations. Think about a scenario where someone asks about a very specific product return policy. Without the ability to access external tools and chain together multiple steps, the LLM is flying blind.
So the chain is more than just stringing prompts together. It's about creating a structured workflow. Let's start there. Explain chains like I'm a smart engineer who's only ever used LLMs directly.
Think of a chain as a software pipeline, Shrija. You have a series of connected components, each performing a specific task, passing data to the next. Instead of a single LLM call, you're orchestrating a sequence of LLM calls, data transformations, and tool invocations. Each step refines the information and gets you closer to the desired outcome.
Okay, pipeline makes sense. But what are the common types of chains? Are we talking about just sequential chains, or are there more complex branching patterns?
Great question. Sequential chains are the simplest. Step A, then step B, then step C. But things get really interesting with things like router chains, where the output of one step determines which chain is executed next. Imagine a customer support bot that routes inquiries to different departments based on the user's initial question. Billing goes to one chain, technical support to another. The router chain is the traffic cop directing the flow.
So a router chain is essentially a conditional statement built into the workflow. But how does it decide which chain to execute? Is it another LLM call?
Exactly. It uses an LLM to classify the input and then map that classification to a specific chain. Think of it like Netflix recommending shows based on your viewing history. They're using algorithms, in our case an LLM, to categorize your preferences and then route you to the content you're most likely to enjoy. They don't just throw everything at you at once. They intelligently guide you through their catalog.
Okay, I see the power of routing. What about memory? How do chains handle context across multiple steps? Because a single LLM call is stateless, right?
You nailed it. That's where memory comes in. Chains can be equipped with memory modules that store the conversation history and make it available to subsequent steps. It's like having a short-term memory for the entire workflow.
So without memory, the chain would essentially forget what happened in previous steps. It would be like talking to someone with amnesia after every sentence.
Precisely. It would be incredibly frustrating and ineffective. Imagine trying to book a flight through a chatbot that forgets your destination after you've already entered your departure city. Memory is what makes the conversation feel coherent and natural.
Okay, chains are the pipelines. Now let's talk about tools. What exactly constitutes a tool in the LangChain ecosystem?
Think of tools as specialized functions that your LLM can call upon to perform specific tasks. It's like giving your LLM access to external APIs, databases, or even other software programs. Instead of relying solely on its internal knowledge, it can leverage external resources to gather information, perform calculations, or take actions.
So it's not just about querying a search engine, although that's the most common example. What are some more sophisticated examples of tools in action?
Oh, it gets way more interesting. Imagine a tool that can access a company's internal knowledge base to answer employee questions about HR policies, or a tool that can connect to a CRM system to update customer information, or even a tool that can execute code to perform complex calculations or simulations. Think of Uber using a tool to calculate the optimal route for a driver in real time, taking into account traffic conditions and other factors. That's a tool doing real work.
Okay, so tools are the action takers. But how does the LLM know when to use a particular tool? Does it just randomly decide to query a database?
No, it's not random. That's where the orchestration layer comes in. The orchestration layer is the brain of the operation. It's responsible for deciding which chain to execute, when to invoke which tool, and how to pass data between them. It uses the LLM's reasoning abilities to analyze the user's input and determine the appropriate course of action.
So the orchestration layer is essentially a decision-making engine that sits on top of the chains and tools. But how does it actually work? What are the key components?
It's built around the concept of an agent. An agent is an LLM that's been trained to use tools. You give it a set of tools and a goal, and it figures out how to use those tools to achieve that goal. It's like giving a project manager a team of specialists and a deadline and letting them figure out how to get the job done.
Agent. That sounds a bit autonomous. Is there a risk of the agent going rogue and misusing the tools, like accidentally deleting a database or sending out spam emails?
That's a valid concern, Shrija. Safety and security are paramount. That's why it's crucial to implement proper safeguards such as access controls, rate limiting, and human-in-the-loop verification. You want to make sure that the agent is operating within predefined boundaries and that its actions are always auditable. Think of it like Amazon's robotics warehouses. They have sophisticated safety systems in place to prevent robots from colliding with humans or damaging equipment. It's all about designing the system with safety in mind.
Okay, safety is key. But let's say I've built this amazing LangChain application with chains, tools, and agents. What's the single biggest mistake that engineers make when deploying these systems to production?
Here's where it gets interesting. The biggest mistake is treating it like a black box and not monitoring its performance. People assume that once it's working in development, it'll just magically work in production. But these systems are complex and dynamic. You need to constantly monitor their performance, identify bottlenecks, and adapt to changing conditions.
So it's not a set it and forget it kind of thing. It requires ongoing monitoring and optimization. What specific metrics should engineers be tracking?
You need to track things like latency, error rates, tool usage patterns, and even the quality of the LLM's responses. Are the chains executing efficiently? Are the tools being used effectively? Is the LLM providing accurate and helpful responses? You need to have visibility into every aspect of the system to identify and address potential problems. Think of it like Google monitoring its search engine algorithms. They're constantly tracking user engagement, search result quality, and other metrics to ensure that their search engine is providing the best possible experience.
Okay, monitoring is crucial. So what's the practical takeaway? What should an engineer do differently after listening to this? Give me 3 actionable steps.
First, start thinking in terms of workflows, not just single LLM calls. Break down complex tasks into smaller, manageable steps and design chains to orchestrate those steps. Second, embrace tools. Don't be afraid to integrate external APIs and data sources into your LLM applications. The more tools you have at your disposal, the more powerful your applications will be. And third, monitor, monitor, monitor. Set up comprehensive monitoring systems to track the performance of your LLM applications and identify potential problems before they impact your users. Think of it like this. Chains are the plan, tools are the muscle, and monitoring is the heartbeat.
Chains are the plan, tools are the muscle, and monitoring is the heartbeat. I like that. That's a good way to summarize it.
Exactly. Because building these AI systems isn't just about plugging in an LLM, it's about architecture, orchestration, and continuous improvement.
And if you treat it like magic, you're going to get burned.